I'm going to show, this is Anirban, I'm going to show how to extract information from documents, particularly PDF documents, using the LangChain and function calls, and how to bind it with a pydantic data model and extract the information from the document as a nice JSON format, which is suitable for our document. And we'll do all this using the latest LangChain concepts called function call, the LangChain expression language, and finally we'll use the OpenAI GPT to process this input and present it in a nice way for us. So this is based on the latest tutorial on deeplearning.ai, which is function calls, tools, and agents using LangChain. Just that I'm using a different type of a document loader over here to extract documents, the PDF documents. So, and as we'll see, we might have to experiment with the prompts, with the temperature settings to get the best output. To start with, we'll get started with extracting the summary information. We'll first extract the information from a document without any information extraction or summary generation or anything like that. We'll just extract the raw content of the document. And for that, we'll use the LangChain PyPDF loader from LangChain document loaders. So because here we are using a PDF document, this is an invoice document. And so all we do is loader equal to PyPDF loader, give the path to the document. This can be ignored for the time being. The model is not going to be useful now. And we say documents equal to loader.load. This is another document. So documents equal to loader.load. And what we can then do is it will basically present a set of documents in an array, and we can go through the array. For doc in documents, we can just keep on adding the text. The doc.page content gives the text, right? And we can print that. We can print the page content and see uh, what kind of content we have extracted from the document. Does it look okay as a first step? So I'm going to comment this. I'll comment out the remaining of the code, which is to extract structured info from the document, because we'll go to it when the time comes. So we run this code, and as can be understood, I have installed the LangChain PyPy package in my environment. I have installed the OpenAI, and I've installed the PyPDF package. And once I've done that, I'm good to go. And all I have to do is export the OpenAI API key to the API key that I have for accessing the OpenAI GPT. I'm using the GPT 3.5 Turbo here. GPT-4 is a paid version. I'm not going for that. So let's run this code and let's see what we are getting as the content of the document, this particular PDF. So as we see, LangChain immediately extracted the content of the document, and let's open this PDF in here. So we can see this is a PDF. It is an invoice PDF where there's an order number, there's an order date, there's a payment type, shipping type, store, from where this order is coming, the bill to, the ship to, the price, the item description, right, hands-on, machine learning, etc., net amount, subtotal, and discount, and then finally the final price after discount. So we can see that LangChain did a good job of extracting this. We can see all the information here in a text format, one by one, being presented over here. Now, what if we want to extract the info in a meaningful way? A typical requirement when reading PDFs is to initially generate a summary from the PDF. So let's see how we can do that using the LangChain function calls and a pydantic data model. So for that, what we'll do is we'll define a pydantic data model called overview, which has two fields, the summary and keywords. And the field descriptions as provide a concise summary of the, we can write in a little better way, invoice content, and provide keywords related to the invoice content. So we can extract this stuff, and this is a pydantic data model. Now once we have the pydantic data model, what we do is we convert it to a openai function using convert pydantic to openai function. This is a method which is given from LangChain utils. LangChain utils convert pydantic to openai function. And once we have this openai function, we can basically bind this to the openai model. So here we are using the chat openai model, which is coming from LangChain chat models, right? Chat openai model. We're using the GPT 3.5 Turbo. We can set the temperature, max tokens. Even if we need the top p values, we can experiment with these things. So we created this model. We are now binding this model to the function called the overview function, which we just now described, and we are saying call this function named as overview, and then we create a prompt equal to chat prompt template from message. So we give appropriate message saying extract the relevant information as summary in one paragraph, extract the keywords. We can even say from the invoice because we know we are giving an invoice, and then we use the LCEL to basically invoke this, to create a chain and invoke this particular uh, chain. So basically invoke this chain. The chain consists of the prompt, the output of the prompt. It's a piping operator, feeds to the model, summary model, which is a model with the function call being bind to it. The function call has been added to the model now, and then the output of the model goes to the JSON output functions parser. That is the output we'll print over here. Summary chain dot invoke, and when you invoke the chain, obviously the input is going to be the content of the document which we extracted using the document loader. In this case, the PyPDF loader from the LangChain document loaders library. So that's the input we have got, page content input, right? Which is the text field which we got from that document and which we saw just now printed. We'll remove the print of this. It's not necessary now because we know, yes, it is extracting the document contents. And we'll try to generate the summary of the invoice. Though generally we don't create summaries of invoice, but we can check it out quickly. So it has got one page. That's the one length of the documents because it's a one-page PDF. That's what it's saying. And it's saying that this is the summary I have got for you. This invoice is for an order placed with so and so publishers. The order includes one item, which is also pretty correct. Third edition with a quantity of one. The subtotal is 3,000 with a discount of 300, resulting in a total of 2,700 rupees, which is pretty correct, accurate. The order is being shipped to this Anirban Konar in Kolkata, West Bengal, India, which is me, and it has got a set of keywords over extracted from that. A little more detail would have been good. I mean, the addresses are not included over here. If you see the shop publishers and distributors address or Anirban Konar, what is the address? If we want, we can play around with the prompt and try to add more information. So when you say extract the relevant information as summary in one paragraph from the invoice, mm, we can say include details like shipping address, and distributor address. we can say that, and we can see how that changes the output. So it is still not giving. Probably it's something to do with the settings over here. Temperature, we can make it maybe 2. Max tokens is already pretty good, so I don't think it's set to 2000. Don't think that's going to so now it's giving the shipping address is this, the distributor's address is this, and the keywords is this. So it has uh, got very good summary now, proper uh, proper name of the item being ordered, quantity, the total amount, which includes a discount of 300. Shipping address is in detail over here. Mm. However, I find one thing that the name is missing in this shipping address. So as we saw, we need to play around with some of the things like the temperature settings, the max tokens, and etc. So we can even increase the temperature setting. I don't think we need a max token of 2000 over here. We can decrease it to 1000 because it's just a one-page PDF. We can check once again what comes out. When we ask to add the address, it now it's saying it's for Anirban Corner in Kolkata, West Bengal. The item ordered is this, price is this, making the total of this. I think this is a pretty neat summary, and we can play around with this by changing the hyperparameters and other things, and to see depending on our need. Normally, we don't generate summaries of invoices, but this is just to check it out. And then what is more important for an invoice will go into that. They basically want to get a list of the invoice fields, isn't it? The key value pairs. What is the order number, for example? What is the shipping address? What is the billing address? What is the item being ordered? What is the price? So for that, now we have used a pydantic data model called invoice info, as we can see here. It has two things, only key and a value. Now, this key value pair makes it a very generic data structure which can be used everywhere because the key can be changing. I cannot say key is price or key is item. So it's a key value pair. The key value will be there, and depending on the key, the value will be set. Now, the actual invoice is actually a list of such key value pairs. So we are saying it's a list of invoice info. So anybody who has worked with pydantic data model will know these are all extending from the base model, which is basically imported from the pydantic. Now, once we do this, we same way we create a function, OpenAI function from this data model. We say convert pydantic to OpenAI function. Now we give the invoice data model as the input. Now, instead of the summary model, we will now have the extraction model. Concept is the same. We basically use this particular function, invoice tagging function, now as to bind into the chat OpenAI model, right? And the function name is invoice. Now we create a chat template with the appropriate instruction and use the LCEL to extract that document. So here we are. So we are giving passing this message. An invoice will be passed to you. Extract from it the invoice info, like item sold, price, discount, shipping and billing addresses. Consider the discount from the appropriate field in the invoice. Extract the final total price from price and discount. Okay, we can leave out this price and discount as a key. So I was experimenting with the prompts, and I found that this kind of a detailed prompt works better. We can try with a much less detailed prompt, and we can see what's the output. I'll just store it somewhere for later use. So let's say if we pass a prompt like invoice, we'll also extract from it the invoice info as key value pairs. And we now use LCL to create a chain. Just one difference here we are using the JSON key output functions parser instead of the JSON output function parser, and the key name is invoices. Where is this coming from? This is the list of invoice info, the invoices, the list of invoice info. So the key has to be this. So we are going to now invoke this. I'll comment out the summary chain invocation. We are now going to invoke the chain to basically use this prompt, and this prompt is feeding to the extraction model, which is using the invoice tagging function, and the output of that is going to the JSON key output functions parser with the key name invoices, and wait to print the result of invoking this chain with the input as the text we have extracted from the PDF. Let's see how it works. So it says key order number value is 32646, which is pretty good. Order date, pretty good. Payment, pay by CC Avenue, which is good. Shipping, speed post or courier, store, shop publishers with all the details, which is also pretty good. Bill to, all the details. Ship to, entire details with the address. Item description, pretty good. The book name, right? And we have the entire book name here. Quantity is 1. Price is 3000. Discount is where we have a problem. Tax is blank. Net amount is 3000. Subtotal 3000. Shipping is 0. Including discount 300. Total is 2700. So it is given the total over here, but it is also given the net amount here as 3000. This is probably because there is a problem with the PDF. So there is a amount here where it says 3000, and if you see under the discount it's a blank, and it has got the subtotal. The shipping is 0, which is correct. Including the discount, the total is 2700. A little bit of a confusion here, so if we make it a little more uh, a detailed prompt like I had earlier, so I will now use this prompt. We'll initially not say key value pairs, we'll invoice info like item sold, price, discount, shipping and billing addresses. Consider the discount from the appropriate field in the invoice. We are adding this because we know the discount could be confusing because of the PDF's layout. Extract the final total price. Let's not say as a key. And let's see if we change this. I will, the temperature 1.5 may not be needed, a default setting. We can even just remove these things and check it out. Really, how what comes? Can remove these things. Check it out what comes. Item description, which is correct. Price 3000, discount 300, shipping 0, bill to is correct, ship to is correct, total is 2700. This is pretty good. The only thing it has missed is the distributor address, which was there in the previous case. The order number, the order date, these things have got missed out. So it could be because I removed these settings. So I'll go back and add these settings which I had earlier. And let's see if we use this, does it add the order number and order date and stuff like that. Total is fine, price is fine, discount is fine, shipping is fine, item is fine, but the some of the key info which we got earlier, like the order number, order date, these have got missing. So this is the way we have to fine tune basically. I don't know whether this I had changed in between, whether that is causing that, or do we have to give some more specific information. Let's try out with this. I don't see any reason why the order number and the order date should not be extracted. Okay, we still see it is missing the order number and the order date, but it has got the price, the discount pretty good, shipping address, billing address. The first part of it got excluded. Okay, so what we can do is, I remember extract the relevant in, this is a prompt now, extract the in from it the invoice info. Yeah, invoice info, we remove this as key value pairs. We'll add this stuff and then we'll say extract keys. So because I have been very specific with items sold, price, discount, shipping and billing addresses, it is only extracting that now. So maybe I will remove this totally and let's see what happens in that scenario. There's something of a delay happening here. I'm not sure what's the reason. Maybe some issue with my internet connection or something. Should not take this long. Okay, so now this is a much better extract. We have the order number, we have the key, order date, we have the payment, we have the shipping, we have the store, we have the bill to, the full address, we have the item description, which is correct, we have the quantity, we have the price. Now, this is where the discount is sometimes causing a problem. It is coming as hyphen tax and hyphen net amount is 3000, subtotal is then it gets shipping is 0, discount is 300 and total is 2700. So what we can instruct it is give the final total price. Key value pairs, consider the discount from the approved date field in the invoice, check the final total price. So trying to see how we can remove this discount and include discount. Consider the discount from the appropriate field in the invoice as one key. Do not repeat any key and extract the final total as one key only. So let's give this kind of a information and let's see how that works. Final total amount, discount. We still have got item discount, item tax. So we'll have to play with this little more. item price. That's a little bit because of this PDF. It's saying here it looks like there's no discount and the total amount is this. And again here it's saying there is a discount and the total amount is 2700. So GPT is going by this. The net amount, it shares 3000 over here. It's extracting this and then again it's extracting as 2700. So we can write a logic to check the total amount and the discount of 300 over here is there. So we can always so there is item price. We can be more specific and let's see how that changes output. Yes, so we still have got the item net amount, key subtotal, shipping fee 200, discount 300, and the final total is 2700. We have got all the things. A little bit of a problem here. Item price is 3000, which is perfect. Item discount, item tax, item net amount. So this is because of the layout of the PDF. Uh, Discount from the appropriate field in the invoices. Appropriate field in the invoice. Do not repeat the discount price. Let's rephrase it a little bit and see if we can fine tune the result. Okay, it has got all these things. Item description, this is pretty correct, but it has added everything to the description. Okay. So this is not the correct prompt. To revert back to the prompt that we had, it's pretty good that it has extracted the website, item website as one field, which is what I saw just now. That it has extracted the store website as a separate field, store email as a separate field, though there is no key for that. That's the intelligence it's showing. It has got the store address, store contact as one field. It has got the store name and store address, all these as different fields. So there is no such key over here, which is pretty good. That the last result I think was pretty good, and we might have to write some logic to disregard the discount that is coming as blank from this line and take the discount from the final discount. I think that's what the processing we have to do, custom processing for this PDF. Though I was able to get the correct value some time back, 300, total is 2700. So this is pretty correct. Price this we have to basically ignore this. But if we look at it, it's pretty good. Shipping, store, all these things have come. Bill to, ship to, and all that stuff has come. All the details have come. Right. As key value pairs, consider the discount from the final. Do not repeat discount and price. Let's not make it so verbose. extract the final total. So that's what it has done. So this is pretty good now. We can see all the details have come, and we can see that the item description, the ship to, bill to, the order date, the order number, the payment type, store, everything has come nicely. We can also say key value players, including store details. Earlier, the store email and the store this thing was coming as separate fields. Now it didn't come. You can add that if you want, including store details. Let's see. Probably it is a function of some hyperparameters also. Payment, ship to, bill to, subtotal, key. Shipping is 0, discount is 300, the total is 2700. So pretty good. Ship to is also correct. Quantity is value. Item description. This is not very good. The quantity has got inside the item description. So I might need to go and change some of the hyperparameter settings here, like make it a little more creative. And let's see how that works. So we are saying as key value pairs, this is not having any impact. So let's remove this as key value pairs. Consider the discount. This is also not having any effect. So this is a pretty generic this thing. Let's see how that works. So yes, we have got now pretty good quantity as one, item description correct, the order number, the order date, payment type, shipping, all that pretty good. And the amount 3000, shipping is 0, discount is 300, total to be paid is 2700. So there is a bit of a repetition here. That's because of the PDF layout, and it's not ignoring that information. Uh, we can ask it to ignore the line item and use only the final information, but that will not be good. So because there is one item here, it's probably a mistake in the PDF layout. The discount should have come right here and the net amount here. So anyway, so it has done a pretty good job of extracting all the key value pairs. The point here was how we can extract information as key value pairs from a PDF document using the pydantic data model, which we normally use in REST APIs. But here it has been integrated with the LangChain, and we can use a pydantic data model and convert it to OpenAI function using the LangChain provided utilities, and use that function to bind to a chat OpenAI model and provide the extracted content from a document, and it nicely presents us the output in a key value pair. Here we're not using any OCR technique, any document AI, but simply using the document loader and the intelligence in the GPT OpenAI. We are extracting the content. That's the thing I wanted to show. I was pretty amazed as this capability, because I have done one similar tutorial in the past using Google Document AI, and this output looks even better than that to me at first shot, with just a little bit of change here and there with the prompt template, and a bit of changing the hyperparameter settings like temperature and max tokens. That's all we need to do. Very simple. Use the PyPDF loader, document loader from LangChain library to load the text content of the document, pass it to a function created from a pydantic data model, bind it to a model, chat OpenAI model, and then finally use the LangChain expression language to basically invoke the prompt, the model with the function, and finally pass it to a JSON key output function parser. which is what is giving this output. So with that, I'll go to my next topic, which is how we can query a PDF document using a vector database. But before that, I also wanted to show the summary generation here with a proper document, not from an invoice. So I know I used a invoice to generate the summary, but let's say normally we don't generate summaries of invoices. Let's say I want to generate the summary from a climate change report which I downloaded just now. Let me see that report over here. I hope I can find it out. There we go. This is a climate change report I have. So as we can see, this is a climate change report from the IPCC, and we have got this big report, and we can generate a summary of this. It's a big document, so it's a, I think about 36-page document. So when we generate summary for this, we might run into token limitations, and we want to check that out. I think it's a good exercise to do. I'll go to the next topic. So I'll rename this, pick up the name, and pass it to my function to extract the information instead of the invoice. So now I'll use a document equal to loaded.load. Same way, I'll see this link documents will now give me the how many pages are there in the document. And when I'm adding the text, I'm initially adding all the content from all the pages, and as we'll soon see, we might run out of token limit, and in that case I'll come back here and change the function to pick up maybe the first 8 or 10 pages. Right now we'll keep it as it is. We'll not need any of this invoice thing. We'll only need this overview function. We can use the summary model here because we are trying to generate a summary. So instead of invoice, we can say, and we don't need all these things for the summary. Extract the keywords. My prompt cannot have something with the invoice because now we are not generating summary of invoice. We are generating summary of a climate report in one paragraph from the report. We can say from the climate change report. If we know the topic, if we don't know, we can just say report. That's also fine. And then we can invoke this comment, and I'll comment out this stuff because we are not doing this right now. Okay. So we are invoking the summary chain now with this climate change report, and let's see what the result we get. So first thing we see, we get 42, which means the length, number of pages it's getting from the document is 42. And as expected, it's saying the model's maximum context length is 4097 tokens, but your message has this many tokens, so we can't process this many tokens. Now this is because I'm using GPT 3.5 Turbo. I don't have GPT 4 access with my personal subscription. If you have, you can check out GPT 4. It has a better context length, I think 32K and things like that. So depending on the model that will change. So since I have 4000 tokens limitation, what I'm going to do now is instead of the full documents, I'm going to pass the first 10 pages of the document and check it out how that works. So I've got 4383 tokens now, which is pretty close to 4097 tokens. So maybe I'll use 9 pages. Maybe that will bring the total tokens within the limit. So it's saying it is still having 4993 tokens, and that's because I'm having 2000 tokens in the completion. So all that is included in the final counting. So what I can do is, since I'm not going for a huge summary, and I can say I need 500 token summary. That should be pretty good for any summary document. Let's see how that works. Yes. So this is pretty good. This report summarizes a state of knowledge of climate change, its impact and recent climate change mitigation and adaptation. It integrates the main findings of the sixth assessment report and the three special report. The report highlights the interdependence of climate, ecosystem, biodiversity, and human societies as well as. So pretty good summary. Key findings are presented based on scientific understanding and are associated with an assessed level of confidence. Keywords are this is extracted these keywords. So we can again play around with the temperature settings, and we can see various outputs, how the outputs change, and we can use the best that we have. Where is the problem now? It's in line 69. 69. Okay. I don't know whether this is causing the problem. It was just now working fine. Okay, this is pretty good. So what all I was saying is we can probably change the temperature a little bit and see how that changes. Trying to make it more creative and see how that changes, if anything. This is also pretty good. Integrates main findings from the country with three working with history. The report acknowledges the interconnection of climate, ecosystem, biodiversity, and sustainable development, and emphasizes the need for diverse knowledge and involvement of multiple actors in climate action. It's pretty good summary, I would say. So this is how we can uh, break up the PDF into manageable chunks before generating summary if it's a very lengthy PDF, or we can also experiment with GPT-4 if we have the access to that and pass it more content. One of the another ways I found very interesting to interact with the content of a PDF is basically using a vector database, and I'm going to show that next. So, for example, here this is very simple. I Same way I basically extract the contents of this climate report and climate change report, and I take the entire text from the climate change report, though it's a 40-page PDF. I don't care now. Now I'm going to create a knowledge base, and this knowledge base basically is nothing but a FICE vector index. What I mean is, if it's calling the process text, very simple. We split the document with a character text splitter from the LangChain library using the new line character as a separator, chunk size is 1000, chunk overlap is 200. We let it be the default settings. We create the chunks, and then we create OpenAI embeddings. Right? The OpenAI embeddings basically, again, it is provided by the LangChain embeddings library, and we create a knowledge base called FICE. FICE is one of the most advanced vector indexes available now from Facebook. FICE stands for Facebook AI Similarity Search. And we just pass in the chunks and the embeddings, and our knowledge base is created. I mean, I was pretty surprised at the availability of FICE as LangChain vector store. So LangChain has already given the support to FICE, and we can just create a vector database called FICE over here, the FICE vector index from these embeddings created from the extracts of the PDF. Once we do that, now what we can do is we can take in a query. Let's say I have created a query here. How much was the global, I'll not use this query, I'll use a different query. How much was the global temperature change in 2011 as compared to 1850? That is one thing I found that was there in this PDF. So if I have a query like that, how do I search for this query? I go to the knowledge base and say similarity search by passing in the query. As simple as that. I get a result as the docs, which is the docs which is matching the query results, and then I pass these docs to the OpenAI by loading the QA chain of the LangChain chains model. From the LangChain chains library, we actually use the load QA chain from the LangChain chain's question answering. The load QA chain takes two inputs. It takes the LLM model, which is my OpenAI model. Now, just see the difference here. We are not using the chat OpenAI model. We are using the direct OpenAI model from LangChain. We are saying LangChain LLMs import OpenAI. So we load the QA chain passing it the OpenAI model and chain type equal to stuff. We can experiment with different chain types. I haven't done that right now. And then we say chain.run with the input documents as the docs which you got from the vector search and the query as a query. So now we can see the response. This is optional. Here there is a callback to compute the cost as well. And we can see what result OpenAI is giving us based on the results of the vector search. So let's run this. So it's now extracting the contents of the document using the LangChain document loader as text and putting it into a vector database. So now it says knowledge base has been created. So this is where the printout is coming from, and now it has processed the query and saying my cost is this, and the answer is the global surface temperature in 2011-20 was 1.09 degrees centigrade higher than 1850 to 1900. And this we can see in the document. It is there somewhere in the page 4 or 5 I was seeing in the document. This is where it is coming from. So it has got the correct answer. It also says with larger increases over land than over ocean. So you can ask it other questions, but before doing that, I wanted to do this in an interactive way. Let's say we are demoing this to a customer. Now having this PDFs hard coded here and the queries hard coded and making changes in the code is not a very elegant way of doing this. So we do the same thing by using a Streamlit UI. The code exactly is the same as we can see here, but only thing is we install Streamlit and we say import Streamlit as st. We present a Streamlit title, chat with your PDF. We allow it to upload the PDF, and then from the uploaded PDF we extract the contents, create the knowledge base in the same way, and you take the query input from the user, and then again same process to search the vector database and write out the results on the UI. So let's run this and see how that works. So I'm running my Streamlit function. So it says chat with your PDF. I upload my PDF, the climate change report. Now it's processing it. I can see background in the prompt where I'm running the Streamlit in the logger. So it's now says FICE index created. So it should give me the place, the text box to ask my question. So I can ask the same question that I had earlier. How much was the global temperature change in 2011 as compared to 1850? I press enter. So now it's processing the query in the same way. And once it gets the answer, it should print it out over here. So it says, so this is the correct answer. We can ask it an additional question. How much was that's a question that I was seeing, that the larger increases over land than over the ocean. We can add a little more over here. Let's see how that works. So it again came up with the correct answer. With larger increases over land than over the ocean. It could pick up the correct answer from this 40-page document. So please feel free to play with your PDFs, upload it using a few lines of code to an in-memory FICE index using the LangChain provided facility. As we can see, 40 pages document is nothing, but yes, if you have millions of records, we might need to use a distributed database and all that. And obviously, FICE provides facilities for that. There are other distributed databases like, let's say, AWS OpenSearch or Pinecone and so many other databases. And but the basic procedure remains the same. We search for the documents using a vector search and pass it to the openai function with a question answering type of an interface. So this is what I wanted to show: elegant way of chatting with a PDF by adding the PDF to a vector index and then using the load QA chain from LangChain to interact with the vector database. Hope this was useful. I used some of my recent learnings from deeplearning.ai, thankful to them, and I've just modified the code a little bit from the examples provided. So anybody who has gone through those courses will find it very easy to follow. And some of these articles I've read on the internet, I've taken the input from that. But it's really good how LangChain is providing various kinds of facilities to basically to interact with your data, to extract information from the data, create vector databases, create chunks, add it as embeddings to the vector database. So even this OpenAI embeddings, as we were saying, it's coming from LangChain embeddings model, and everything coming from LangChain, it binds together very nicely, and the code becomes only a few lines, very easy to understand, and can be demoed quickly to the customer as well. And for production release, of course, we'll have to load balance it, scale it up, and deploy it on a proper cloud server and all that. So with that, thanks for joining today's session, and thank you all for listening.